Hi guys. Oh, hello there. Sorry to keep you guys waiting for like 7.5 minutes. Alright, I see 3 sit-ups. Immediately right off the bat. Okay. Hey, a year! Thank you for the 12-month sub, Bellum. It's been a year since I met you. Yeah, congratulations. It's been a year since Bellum watched me painfully put that Ender 3 Pro together for like 2 weeks. And now, I have like 14 of them. Thank you, Ad Sandwich, for the Prime sub for 7 months. Alright, let's do it. Let's do my 3 sips first. Alright. Being notoriously bad at exercise, otherwise, I'm actually pretty good for sit-ups. Push-ups are the bane of my existence, and don't even get me started with pull-ups. Alright, here we go. 1, 2, 3, and one more just to get back up. Redeem do 6 squats. Okay. Okay. Alright, squats are the ones I'm not good at. I have fallen over multiple times because of this. I should get some light in here. Hold on. Floor lights. Side lights. My $40 Amazon hotel lights are worth it. Alright, there's like no space here, so I'm just gonna... Alright, here we go. 6 squats. Alright. 1, 2, 3. Oh, I'm starting to feel it already. It's 3 squats. 4, 5, 6. Alright, that wasn't too bad. I do not like squats. They make my legs feel terrible in a day. Oh, Hype Train is close. Nice. No, 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 Huskabite, no. I go to the gym 3 days a week. I should make you work out too on those days. That's what all my friends say. They want me to start working out. I politely decline. Except for Twitch. Alright. So where were we? Yesterday. What were we doing? I need to get a new PC. Like, this computer sucks. Alright, like an actual PC this time. Right, I was doing this stuff, which I haven't saved it yet. This is beginning to look a lot more like the MIT did. That's out! You haven't seen it yet! You haven't seen it yet. Things that rotate. It's fine. Yeah, I pulled like 2 all-nighters doing this for Friday. Anyways. That. This contains over 1,000 screws. We verified it in stream. And then what I'm doing here is I'm making it into an RC car. Just because. Wheel design and all. I still don't like this design. Save it for yesterday. I don't like it. 1,376. It's about 1 to 1.5 kilograms of plastic. The numbers of screws traumatize me enough to everyone the exact number. You have dozens of RC batteries. No, I have 8. You want to see where the robotic arm is? You want to see where the robotic arm is? Boom, there's the robotic arm. It's not even on a battery. Let me just change that real quick. Boom, there's the robotic arm. Look at it grabbing the battery out. Look at that. Look at that. So the entire battery chamber rotates, right? Right? Oh, it's on the other side. I didn't feel like putting it in. The robotic arm just needs to do a 180-degree turn from the drone. You know what? I'll put it in. I'll put it in. Where is this? Where is your thing? Oh, here it is. This is gonna lag immensely. Give it a second. So the idea is that from the ground station to this thing, there's a 180-degree turn with a loading platform. And this is so that... Oh, goodness. Okay. So the idea is that the drone and the ground station are on one side. This thing is on the other side. And the robotic arm just does a 180. And it kind of works. My computer's not going to like this. Come on. $145. There you go. Boom. So from ground station to battery chamber, 180-degree turn. So that you don't have to like precision slot it in. You can just like program in one command, go from point A to point B. And then we have a planetary gearbox in the middle with the Dynamixel motors that they provided for us during the summer. At least that's the gist of it. I should explain to you later that sandwich. Alright, so design time. Make this like 30, 25. The solar system gearbox. Yeah. Basically, I have this really insanely heavy stepper motor that's going to be in the center of this whole thing. And then there's going to be these two expensive motors. But this thing was like $30. These two motors were like $500. I still can't wrap my head around that. This is to give it a lot of torque. I just smacked my head with it. And these are going to help it turn. 500, yeah. Dynamixel motors. I haven't even considered the electronic assembly process for this. So. More servos. Unfortunately, Robotis does not have servos. Our sponsor wants us to use the motors, and I'm going to use the motors anyways. They're just for giving us more force to work with, really. Yeah, yeah. No, because like the dynamics of motors have like an insane encoding system that we can use. How was I gonna do this? Got light, so we got E20. It's supposed to pay for. Yeah, no, like this project, I'm not paying for out of my own pocket. I mean, technically, I am for the moment's being, but like, we have a sponsor that gives us stuff. So I'd very much like to use the sponsor stuff. In that case. If it were me, I would just use like regular servos because I'm cheap, and I don't have the money for that. That looks pretty cool. I'm going for the flashy factor with these wheels. Servos won't do the wrong stepper wheel. Oh no, that is a stepper, not a servo. Sorry, that is a stepper motor. I do also have a stepper driver. Let's see. .216. Close enough. I'm gonna mark that off as aerodynamics. If they ask me why the complicated design. Okay. Do I want anything on the rim? Why is there this little piece here? I think I might make a TPU rubber wheel around this. The dynamics are power servos. The ones that they gave me are actually actuators. Yeah. What was he doing again? Right. No, I need a tangent plane. No, I need to make the TPU thing. So this is going to extend outwards into the floor, but I hope it's going to provide some cushioning. Alright, so that's the TPU cover. I have no idea if the tolerances are correct or not. We'll figure that later. Hopefully the tolerances are tight enough to hold together. And then I can go ahead and draw some fancy shapes on the side of this thing. Okay. So the circumference of this thing is 224.624. Even more fancy shape, indeed, yes. Can't get enough of the fancy shapes. So 224.624. Okay, I have this much room to work with. Let's do some tangent lines. I love my tangent lines. Wait, why isn't that line? Ooh, I have to get the Hyperloop rolling again. Maybe we'll do some Hyperloop next week. That's a fat tangent line. Okay, that'll work. Okay. Let's go all the way over there. Alright, rectangular pattern. All right. Emboss. That's a terrible tangent line, all crooked. What do you mean all crooked? It's not gonna look all crooked when it's mapped onto the wheel. That looks fine, right? Slightly questionable, actually. Oh, also it splits the, Ooh, I forgot to do something. I forgot to do an offset for the, for this. So that doesn't emboss all the way. Or, no, I can just do this. I can just do this. Yeah. Okay, that works. The first thing you drew, that was before you fixed it. Oh, okay, yeah. That's pretty good now. I'm... Alright, good enough. Okay, so... Render. I'm gonna color this thing first. I'm gonna color it. Orange. There are no orange displays. Great. Red. Yeah! Red rims. Okay. So now to figure out how far this is from the actual motor itself. Because none of what I do here actually has dimensions. Like dimensions? What are those? Oh! Hello, Ilisja. Thanks for, coming to the stream. It says you're listening only, but hello. Multicolored shiny things. Multicolored shiny things are very, very appealing to the eye. Alright, how far is this actually going to be from the, where's my motor? I guess I'll need a cata motor. Fine, I'll cata motor. The one on the side here. So this motor is approximately 37 millimeters. 37 millimeters. Let me just hide this first. Is approximately 55 millimeters thick. Maybe 56. And then on the other side, it has a little shaft. Cadarsa Redeem saved my work. Oh yeah, thank you, Cadarsa. 6 millimeters. 6 millimeter shaft on the end, and then extruded to 20 millimeters. lamb motor. What is this big wheel object? Oh, this is the rim. Alright. Create components. Components. Component. RC setup. Okay, I'm gonna drag all 4 of these inside. All right. So first, I'm gonna go ahead and joint this portion of it into the inside of the motor holder. Motion, I'm gonna give it a sliding motion. Yep. Okay. And then that fits almost. Actually, will that hit anything? Barely. Okay. Might just screw this a little bit more then. Will that hit anything? Barely. Okay. Some very tight tolerances here. Okay, and then we get to the wheel. I'm gonna joint this thing to this thing. I'll give it a rigid. That was a fun shake. Okay, and then I'm going to joint the back piece. Oh, that's a pretty long piece. Right, I realized that this thing does not have anything to hold up with because there's a metal coupler in the middle. Okay. I would go ahead and joint the center of this thing to motor. They'll give me an approximate size, I think. Okay. Now for the grand reveal. Oh, hold on. Almost forgot to joint. Oh, stop rotating. Yeah, rigid. Yeah. Okay, this one was a bad choice. Oh, come on, let me edit. There we go. Good water displacement. Thank you, Kandarsa. See, someone appreciates the tangent lines. Alright, wheel is done, so I'm just gonna copy paste this. 8. Okay. And then joint this piece with this piece. All right. And with that, we've just turned this battery into an RC car. Yeah! Yeah, look at it go. Let's do a motion study on this thing. I want to see what it looks like. Look at it go. That's fun. And I can do the same thing for this one, I think too. Now both of them are gonna turn. Oh, we can do it front and back too. Let's see it. Yeah, look at that. Wheels. All right, this is definitely not gonna print well though. All right, we have completed. Let's render a thing. This is what it looks like when it's rendered. Nice shiny RC car built out of a Forest LiPo battery case. Look at that. Alright, what's next on the list? Design motor holder, design wheels. That's so much shinier in UI, I know, right? Rendering always makes things look cool. So we did design motor holder, we did design wheels. You guys can't see the rendered design because the thing's in the way, but here we go. My stream's also gonna lag because it doesn't like rendering these things. So turn battery chamber into RC car, we finished that. Just check that off on the list. Alright, we've done 4. Okay, next is slot for the FPV camera. I'm gonna take a picture and put it in my Discord. Okay, next is adding the slot for the FPV camera. So a while ago, no, I don't want to do a generative study. A while ago, I bought this little tiny FPV camera that I have no idea how to use. It looks like this. It has an antenna, a small camera on it, and I think like a back for addressing things, maybe. I don't know. I just thought it would be cool. Little thing, and I kind of want to use it. Apparently it's very powerful. It's kind of like the same as the iPhone camera. So, mission number 2 is figuring out how to strap this thing onto the battery and then read from it. Because, theoretically, if you want to make this like an actual RC car, it would have to go somewhere on the front, and the wire goes into the PCB. and they were able to see stuff on it. Send me a link to it? Yeah. Oh, that's how it's gonna know how to use this. It's a small FPV camera that transmits signals through a radio frequency, a radio channel. Where are you? Oh, here you go. Oh, by the way, Ed Sandwich, the fans work great. Belty had this issue where, like, if you turned him on, that Belty over there, it would make this really high-pitched whirring noise from the PSU fan. That was really, really annoying. So I asked Ed Sandwich to send me a recommendation for another PSU fan, and it turned out that all the good ones are sold out. So he just gave me one by default from Amazon. It worked, so Belty has been healed. Part shortage moment. I mean, you think it would be like a chip shortage, but also apparently it's a fan shortage as well. You know, these things can rotate as well, I think. Yeah, they can. Okay. So I'm going to work on a mount for this. I'm going to put it somewhere up here. Maybe. Now this shouldn't be too difficult. Where did I put it? Here. It's a shipping shortage, really. Glue shortage. Shipping shortage, really. Not even a manufacturing shortage. Supply and demand issue. Yeah, I heard that China has been having like supply chokes for the longest time because A, COVID, B, China. Look, I started cornering the market. I did buy a bunch of parts recently for PCB design and also like the soldering kits and all from China. Now the rest of us are struggling. Alright, so how am I gonna design a case for this? Well, the most important part is the camera itself. And also the back part where you can see which address it is currently on. I think this is 5 volts. Not sure. Okay, so let's see. The base of it should be relatively easy. By the way, this is like the most chalk-filled PCB board I've ever like witnessed in my life. Every single square inch of this PCB is filled with components. This FPV is a VTX with an omnidirectional antenna and one piece. You need a VTX receiver, likely with a patch antenna. That was what I was thinking as well. I need one of those devices where like it has that antenna attached to a visual monitor in which you can see what's going on it. I looked into this for like approximately 3 minutes, but like I want to find a way to put this onto like a Raspberry Pi or something like that. I think that'd be cool. It's a tiny camera. So the base of it is going to be, let's see. Okay, the actual object is about 20 millimeters in length. I'm going to give it a generous 20.5. Here, project this. Okay, so it'd be centered there. And the base is about 20.5. It's very small, actually. And the width is approximately over 10 millimeters. 10 millimeters. It's a very small camera. I have an ESP, it's an ESP32 camera, it works well enough. Oh yeah, I wonder if I can put an ESP32 in this thing. I probably can. Good idea, Canarsa. Good idea. Alright, then I'm gonna make a border around it. So it's gonna be a 5mm board would be 30.5, right? Okay, and then by 30? No, by 20. I'm gonna divide that by 2. I'm gonna give it 2.5 on each side. It's a very small design. Maybe 25.5. 2.5, yeah. Okay. And then give it a base of around 2.5. Oh, there are 149 sketches. Lovely. Then the outer shell, the height of this thing is around... I'm gonna go 15. So 15 plus 2.5 is 17.5. Okay. All right, now we make some cuts in the middle for the cameras and stuff. So if this entire thing can fit inside this little box here, the sides don't need to be touched. The center does need to be touched. Should go almost all the way down. So let's see what I need. What parts I need to cut out from the back. So the first thing is the center camera. The central camera is about 9mm. Okay, so that'll be for the camera, and then from the back there's an LED looking thingy on the back here. This thing is about 7.5mm. And then on the right side there's a wire sticking out of the top, so that is going to be five millimeters. Okay. From this to the bottom, it's 11.5. Negative 11.5. Oh, same for the other one, I believe. That one's 10. Negative 10. And then this one is negative 7.5. Why are these all three of these different? Okay. So I should be able to just slot the FPV camera inside this. And And then maybe I can have something, another part, another small part screw onto it. So I sent you a receiver that can do what you want. You can use the pinouts to connect to RPIT and then library to decode the video. The encoding for your video transmission is NTSC. Oh, that's useful. Thank you. Let's see this. SkyDroid 5.8G dual receiver. Wow. Cool. Awesome. Thank you. But I'll still research more for one where you can look into the channel because it switches to the strongest signal. Ah. Yes. That exists. Okay. Alright, so it needs a top piece to act as a cap for it. I'm gonna go ahead and put some fillets on this entire thing though, just to make it look pretty. All right. And then from the top, wow, I already generated these holes for me. How convenient. From the top here, I'm just gonna edit the sketch a bit to complete it, just to make a cover. I can screw on. Oh, I have to make sure I don't block the back part of it, I think. So that would be this part. Actually, it should be fine. It should be fine. Okay. And now I make some holes. This model is lagging my computer so hard right now. I just don't know if there's one that just has the pinout that does it cheaply. Drink some water, I don't know. Okay. I think these holes are good. I mean, it auto-created them for me, so who am I to disagree? I do need one more here, though. Okay, I think these holes can be, they don't have to be M3s. Because M2.5s are so large already. I think they have to be M2s. Yeah, they have to be M2s. Scrolling back down to the sketch. So it'll be M2 by 5. M2 by 5 it is. Okay. That part will go on that part. The back will be open. Alright. That's basically it. Very easy camera module. Now I just have to apply some screws on the bottom to attach this piece to the battery chamber, and then we'll all be good. So this will most likely be screwed onto the battery chamber from the bottom. So under the battery chamber. Bottom, I'm gonna hide everything else. So on the bottom piece here, hey Huskaby, here, we're about to get some more screws. There's 5 more screws times 8, which is 40 more screws, plus the bottom piece, which is gonna be, let's see, how many screws do I want here? Slowly getting closer to the goal, 2,000 screws. Just an FYI, the VTX models get hot as heck. It might melt PLA views for more than 15 minutes. Noted. Noted. Time to use resin. The fire department is now knocking and trying to preemptively extinguish fires. Oh, Huskaby, you weren't here when I had that incident with the resin printer. I spilled resin all over the place, fumigated my room, and this place was unlivable for like 2 days. That was only like a couple months ago. We are the best of friends. I don't know what you're talking about. These can be M3s. Oh, this is going to be a fat M3. Okay. 6 to 3.5. And then I don't know how deep this is. I'm just going to guess. 10. Oh, that's close. 8. 8. 9. That's close. It's 8.5. Yeah, it's 8.5. Okay, from the bottom. Hole. Hole here, tap, simple. Okay, let's do some math. So if it's 8.5 all the way through, and it's 2 millimeters deep, so that's 6.5, that means I need an M3 by 8, so this will go, no, 3 by 10, so this will go 2.5 deep, but the bottom floor is not 2.5 deep, it's only 2. It's like 2. Therefore, M3 . 1.5. This FPV camera is gonna fly off into the distance. I can already see it. All right, good. FPV stuff. Whoa, whoa, whoa. Okay, we're in business. Let's color this thing. What color do I want this to be? Let's see, I already have red. I already have silver, I already have white. Is there a green? There is a green. I can have this be a glassy green. Or a clear green like that. Alright, look at that. We're already done with another one. FPV camera slot done. I'm gonna look so cool pulling up to school next week. Pink. Alright, Bellum, I'll make the next one pink. I saw that a little bit too late. Alright, I can check mark the add slot for FPV camera now. Next is drone attachment mechanism, which I'm going to do later. I'm going to render this to show you what it looks like when it's rendered. Add sandwich. If it gets hot enough to melt PLA, it's like over 160 degrees Celsius. Shiny. Thank you for joining me on another episode of Questionable Engineering. Now let's see what it looks like if I actually place this model inside the actual battery arc. And then I'll end the stream here for today. So the battery arc, I have to go ahead and get latest version. Oh, I can foresee collisions. I can foresee many collisions. Oh, it's calculating. It's calculating. Why pick between fashion and function when you can have both? Exactly. It's calculating. Please don't crash. Every time it tries to calculate something, Fusion crashes. I'm gonna need a new PC just so that doesn't crash. Oh? Uh-oh. Oh no. Wait. Oh no, what's going on? There are wheels everywhere. Okay. Yeah, I don't think it did like that. I do not think it liked that. Can I undo that change? Okay. This will be forever stuck in V32. No one touch this. Choose version. Yes, version 32 is stable. Oh my goodness. Okay. Good. Alright, drone attachment coming tomorrow so that the drone can deploy batteries and stuff. And yeah. Okay. That'll be it for today. Thank you guys so much for coming and watching my stream. I'm gonna go do something else for now. Alright, who are we rating? Akenshi? We're rating Akenshi. I'm leaving you, yes! For now. I'll be back tomorrow though. I promise. Wait, tomorrow's Monday. Yeah, I'll be back. I better go to sleep. That is a questionable statement. But thank you guys so much for watching this stream today. No sleep, only work. Yeah, see, Canarsa gets me. Canarsa gets me. Wait, before you go. Well, you have approximately 30 seconds before it kicks me off to a Genji stream, so... Speak now or hold your truth. Hold your... Or stay silent for... Or whatever that saying is. A workout plan? If only. Alright, you guys get until the end of that timer to complete, but thank you guys so much for watching. I hope you have a great rest of your night, and I'll see you tomorrow, alright? I did do 6 squats already! My legs are already in pain. What else do you want from me, guys? But I'll see you guys tomorrow. Bye-bye. Yes, a whole 6 squats.